calculus, not only do we have to be able to solve equations, but quite often we have to be able to solve inequalities, where you have less than or greater than. Now, I want you to think about the fact that when we were talking about polynomial functions, we were always focusing on zeros. In this case, we have 4 zeros. But now I want you to focus on the other parts of the graph. Sometimes the graph was above the x-axis, and sometimes the graph was below the x-axis. When it's above, we call that positive. When it's below, we call that negative. So if I have an inequality like this, x squared minus x minus 12 is greater than 0, I'm really asking, when is this parabola greater than 0? Well, first, I'll figure out where its zeros are by doing the usual. If I factor it, this is x minus 4 times x plus 3. But the question isn't where is it equal to 0 now, it's where is it greater than 0. I know it's equal to 0 at 4. I know it's equal to 0 at negative 3. So I'm going to put those two numbers on a number line. It must be greater than 0 in between, on these intervals. Sometimes it's greater than 0, sometimes it's less than 0. So all I have to do now is just test. Just test these intervals. Like take a number like 5. 5 minus 4 is a positive number. 5 plus 3 is a positive number. I don't even care what those numbers are. I'm just pointing out that if x is 5, both of these factors would be positive. So this parabola must be above the x-axis. It must be positive to the right of 4. But now take a number in the middle interval, like 0. 0 plus 3 is still positive, but 0 minus 4 is negative. And when you multiply a positive times a negative, you get a negative answer, right? So this parabola must dip below the x-axis in between those two numbers. And then if you come back over here to a number like negative 4, negative 4 minus 4 is negative 8, and negative 4 plus 3, now that one's negative. Negative times a negative, we're back to a positive again. So what was the question? The question is, when is this polynomial greater than 0? This number line tells me my answer now. All of these numbers make it greater than 0, so that's part of our solution. And then all of these numbers make it greater than 0, so there's the rest of our solution. X is either less than negative 3, or x is greater than positive 4. That's the solution to that polynomial inequality. Now it works the same for rational functions as well. If I have rational functions, they usually have asymptotes, but sometimes they're above the x-axis and sometimes they're below the x-axis. Up here is where the function's positive, down here is where the function's negative. Suppose we had a question like the following. I'm going to give you a rational function, and I'm going to ask the question, where is it greater than or equal to 0? Let's say we have a rational function that has 2 factors in the numerator and 2 factors in the denominator, and we want to know where is it greater than or equal to 0. Now let's say that our factors are 2x plus 1, x minus 3, x plus 7, and x minus 4. I know from my work with rational functions that this thing is 0 2 places, and it's undefined 2 places. So what I'm going to do is put those places on a number line. It's 0 at 3, it's 0 at negative 1/2. It's undefined at 4, and it's undefined at negative 7. Okay? Now, the question is, when is it greater than or equal to 0? Well, we know it's equal to 0 at negative 1/2. And we know it's equal to 0 at 3 because those are the two places where the numerator is 0. However, it's not equal to 0 at 4 or negative 7. Those are the two places where it's undefined. So I figured out where it's equal to 0. Now I'm going to figure out where it's greater than 0. And we do it just like we did with the polynomial one. We test each interval. Let's start with 5. If x is 5, this factor would be positive. 5 minus 3, this factor would be positive. 5 minus 4, this one would be positive. 5 plus 7, this one would be positive. Out there to the right of 4, everything is positive. But if you took a number like 3.5, 3.5 would make that positive, but 3.5 minus 4, this factor here would become negative. And if you have one negative factor, it makes the whole thing negative. If you take a number like 0, which is in this interval, this would still be positive, but 0 minus 3, see now this would be negative. And a negative divided by a negative, you're back to a positive again. If I take a number over here, like negative 2 or something, negative 2 times 2 plus 1, that one would become negative, but nothing else changes. So now I have 3 negatives, and my answer is back to negative again. Finally, if I take a number like negative 8, notice negative 8 plus 7, now even this one's negative. If you have an even number of negatives, in this case 4 negatives, then your answer is back to positive again. So it's pretty easy to figure out on which intervals it's positive and on which intervals it's negative. Our question was, when is it greater than 0? Well, greater than means positive. So this interval out here works to the right of 4. This interval in between negative 1/2 and 3 works. And this interval over here to the left of negative 7 works. Our answer has 3 different parts. But again, notice I did not include negative 7 because that's where it's undefined. And I did not include 4 because that's where it's undefined. But I did include those two numbers because that's where it's equal to 0. So this is a graph of our solution set. Now, if you want to write it as inequalities, you could say x is less than negative 7, or x is in between negative 1/2 and positive 3, or x is bigger than 4. Notice I included the negative 1/2 and the positive 3, but I didn't include the 4 or the negative 7. So it really doesn't make any difference if it's a polynomial function where all of your factors are in the numerator, or if it's a rational function where some of them are in the denominator. You do it essentially the same way. You figure out where each factor is equal to 0, put them on a number line, and then test each interval. Now, a common mistake. It looks like both examples that we did, if it was positive on one interval, then it would be negative, and then positive, and then negative, and then positive. It looks like that it just alternates, flip-flops, positive, negative, and so forth. But I want to remind you that that's not always the case. If I have a parabola that looks like this, even though it's equal to 0 at some number, it's positive to the left of that number, and it's positive again to the right of that number. So don't get in a hurry and assume that it's always just going to be plus minus, plus minus. Let me show you another example. Let's say we have 2x plus 1 times x minus 7 squared over x plus 3, and this time I'm going to make it be less than or equal to 0. Right? So here's the idea. I draw a number line, and I figure out all the places where all these factors are 0. This one's 0 at negative 3. This one's 0 at negative 1/2. And this one's 0 at 7. Okay? Now I do want it to be equal to 0, so I want to include negative 1/2, and I want to include positive 7 in my answers. but I don't want to include negative 3, so I put a hollow circle there. Solid dot means that number is included. Hollow circle, it's not included. Now I test each interval. I like to go from right to left for some reason. I'm going to start with 8. If x were 8, this would be positive. 8 minus 7, this would be positive. 8 plus 3, this would be positive. Everything's positive out there. Now, watch what happens if I put in the number 6. 2 times 6 plus 1, that's positive. 6 minus 7 is negative 1, but once you square it, it's still positive. Negative 1 squared is positive. 6 plus 3, see, there it is. It was positive to the right of 7. It's also positive to the left of 7. Now, if we take a number like negative 2, negative 2 times 2 is negative 4 plus 1. This factor jumps to negative, and so the whole thing jumps to negative. And if we take a number like negative 4, now this one would jump to negative, and the whole thing becomes positive, because a negative over a negative is a positive. But this factor is always positive, because anything squared is always positive. So to finish it off, we want to know when is it less than or equal to 0. Well, it was less than 0 on this interval, and that's the only place. It was equal to 0 at those two numbers. So we would say x is bigger than negative 3, less than or equal to negative 1/2, or x equals 7. Those are the places that we ended up shading when we shaded the regions that were, right? So it doesn't always flip-flop, plus, minus, plus, minus. You got to be kind of careful. We want to know where this expression is less than or equal to 0. Now remember, less than 0 means negative. It's equal to 0 at negative 1/2. It's equal to 0 at 2. And it's equal to 0 at 4/3. So we have 1, 2, 3, 4 intervals. I'll just test one of them for you. If x is bigger than 2, then this factor would be positive, and this factor would be positive, and this factor would be positive. So we are positive to the right of 2. But remember, we want it to be less than or equal to 0. Here's the solution set that you gave for this inequality, and I can see where you got the negative 1/2, and I can see where you got the 2, but I think you forgot to include 4/3. how you solve inequality. Here would be a simple example. If we had x squared plus 4x
The fuck?
minus 21, and
Hey,
we wanted
Javi.
that to be greater than, no, let's say less than or equal to 0, then what we do is we factor. And x squared is x times x. And this number times this number is going to have to be negative 21. And we're going to have to add up to 4. So we go with positive 7 and negative 3. So now we can see that if x were negative 7, that would make this expression equal to 0. So it's our solution set. If x were positive 3, that would make this expression equal to 0. To the right of 3, like at 4, 4 plus 7 is a positive, 4 minus 3 is a positive, so we're positive out here. If you take a number like 0, 0 minus 3 makes this factor negative, so the whole thing is negative. And then if you take a number like negative 8, negative 8 plus 7 makes this factor negative, and a negative times a negative is a positive. So since we said we wanted it to be less than or equal to 0, we said our answer is this interval. So one way of writing your answer is x is in between negative 7 and positive 3. Alright, all I wanted to point out with this lesson is that there is a nice notation called interval notation for writing these kinds of answers. The left number was negative 7. The right number was 3. So I just put the left number on the left and the right number on the right and put a comma in between. And then, if I want to include those endpoints, I put square brackets. This equal to here means that we wanted to include those two numbers in our set, and so I put square brackets. The square brackets mean that 3 and negative 7 are included. Now, if it just would have been negative 7 is strictly x, less than x, which is strictly less than 3, now it doesn't say equal. That would have been the answer to this inequality. We don't want it to be equal to 0. We just want x to be in between. So how do you indicate that you don't want to include those endpoints? Well, when you don't want to include the endpoint, the only difference is you use a parenthesis.
Number
Now,
5.
that notation's a little bit unfortunate because people look at that and they think, oh, that's the point, x equals negative 7, y equals 3. It's just got to be understood in the context of what you're saying, that you're talking about the interval from negative 7 to 3 rather than the point negative 7 to 3. So this interval starts at negative 7, ends at 3, but does not include the endpoints. So that's why I put those hollow circles there on the end to indicate that the endpoints are not included. Now sometimes your interval may not have an endpoint. For example, if I just said x is greater than or equal to 5, well, here's 5, and here are the numbers greater than 5. How would I write that as my interval notation? 5 is the left endpoint, and I want to include it, but it doesn't have a right endpoint. It goes clear to plus infinity. Now, infinity is really not a number, so we never put a square bracket on the infinity end. We put a parenthesis there. So that means include 5 and everything to the right of 5. Similarly, if you had something like x is less than 2, here's the number 2. X is strictly less than 2, so We're talking about that interval. 2 is on the right end. It's not included, so I use a parenthesis, and it goes clear to negative infinity on the left. So that would be the interval notation for that set. Okay? You can have any combination of these things. If you had including negative 7, excluding positive 4, we want everything in between, including negative 7, excluding positive 4. So I put my negative 7 on the left and my 4 on the right. I put square bracket there and parenthesis there, and that indicates that I'm including the left end, but not the right end. And finally, if you end up with a couple of intervals, like in the last assignment, we had some answers that maybe look like this. We have this interval, and that interval, x can either be here or here. Let's say that this is the number 2, and this is the number 7, and this is the number 9, and this is the number 12. This interval is the interval from 2 to 7, not including the endpoints. This is the interval from 9 to 12. We call that an open interval when they're not including the endpoints, and a closed interval when it does include the endpoints. But anyway, what you do is you just put a union symbol. It's the union of those two sets. And that means that x could either be in here or here. You might think of that symbol as meaning or. Okay? So that just gives you an alternative way to write answers. Rather than writing it this way, you can write it this way, but they both mean the same thing.
5 is negative 1, and f of 2 is 4. So the slope of this line is 4 minus negative 1 over 2 minus negative 5. Once you know that the slope is 5/7, then you can say that the equation is y equals 5/7 x plus b, where b is the y-intercept. Now to find b, let's just let x be 2 and y be 4. Now it's an easy algebra problem to solve that equation for b. Once you know that the slope is 5/7, then you can say that the equation is y equals 5/7 x plus b, where b is the y-intercept. Now to find b, let's just let x be 2 and y be 4. Now it's an easy algebra problem to solve that equation for b.